Hello. Today we're going to be doing the Centripetal Force lab. We'll be using this apparatus here. You'll see me spinning this, and the idea is as I spin it that this hanging mass is going to be vertically down. So I have to spin it at just the right speed so that it remains just vertically like this, not like that and not like that. Okay, so it's just vertically down, and I'm going to have to fix this so that that doesn't happen. But hopefully it gives you the idea of what I'm going to be doing. I'm going to spin it so that it rotates 10 times. You're going to have to time it from your house. You can use your cell phone or whatever means you want to time how long it takes to go around 10 times. I'll do 5 trials of it at 3 different hold positions. And that will give you the information that you need to calculate the centripetal force, which I'll talk to you about after. Before I show you how to do it, I want to show you how not to do it, or if you ever see it do this, try to avoid the times when it is doing this. So one is when it's just moving too slowly, that it's not vertical. So we don't want to count those turns because it's not vertical. So we're going to get weird data because the speed's going to be different. Or maybe it's going too far out like that. Or maybe, so that's another time not to count it. Or other times are maybe when it's like, going kind of to the side a bit more than it should be, where the string is actually leading. I'm sorry, the weight is actually leading the top right there. Gets into some weird modes. So those are the things to avoid when you're actually doing your measurement, as much as possible. Before I spin this, I need to make a few, a few measurements of different lengths that are going to be important for me to use in the calculations. One of them is the distance from the center of the rotation, which is right here, to the vertical string. So this distance here looks like it's about 40.5 centimeters. So record that. I'll measure 4 distances, although I only ask you to use 3 in the lab. This one here is 37.5 centimeters. This one here is about, looks like about 34 centimeters. And then this one here, the furthest one in, is about 31 centimeters. So 31, 34, 37 and a half, and 40 and a half. Those are your numbers. Record them. That's one measurement. The other measurement you're going to want to make, and I'm going to have to do it from each position that this is hanging, is how far how stretched the string is, or this spring is, not string. How stretched the spring is to go from here to here. That's going to be an important measurement that I'm going to need for reasons you'll see in just a little bit. So from this pin right here, when it is stretched so that it is vertical, the way in the position I want it, looks like the spring is stretched a distance of 35 centimeters. Okay, so I'm going to have to write that one down, or have you write that one down. 35 centimeters, that's for the most outward one. The one that's, I think, 40.5 centimeters. Yeah, the one that's 40.5 centimeters, when it's fully out in the vertical direction, the spring is, like I said, 35 centimeters, like I said. All right, so now the fun part. What I'm going to do is I'm going to stand back and spin this. That's why I'm wearing safety glasses, because this thing could potentially go flying. And I am going to try to get it to spin at just the right speed that the bob stays vertical. And from there, we can make our measurements. And I'll try to let you know when that is, but hopefully you can see it. Once it's vertical, I'm going to try to keep it vertical and have it spin 10 times. And you want to time how long it takes to go those 10 times. Okay, I would say it's approximately vertical there. Hopefully that's more than enough data for one of them. So in the next frame, you're going to see me go into multitask mode. I'm going to be doing 4 of these at once. It was hard to do. But from that, you'll be able to actually get 4 data sets by reviewing the next few minute or so of this presentation again and again, and you'll see what I mean. But each one of the 4 images that you see, or the 4 videos that you see, is a different case. So you'll have a lot of data that you can work with. Remember, you want to count the time it takes for it to go around 10 times. And you can pick your 10 from each of the 4 cases you're about to see. Okay, I magically moved the string from this one to this one while you weren't looking, and then I measured the distance, and so now I'm in the second one in. That is a radius from here to the center of the pole of 37.5 centimeters, if you recall. So if I measure the length of the spring here, I am at about, let me see, make sure I'm as close to vertical as possible. So you can see that. I'll change that angle. And I get about 31.5 centimeters for the length of the spring right now when it's in the second hole. Okay, now I'm going to turn it, and you're going to do the same thing. I'm going to count 10, the time it takes to go around 10 times once it's vertical. Stop it. Okay, so I'm going to multitask again, and you're going to get to do the same thing. Pick your 10 rotations that you prefer, and the next set of rotations that you have, and you'll have your 5 repetitions, with this one being the first. All right, so now I moved it to the third one in, which, if you recall, is 34 centimeters from the center of this to the hook. And I'm going to measure the stretch of the spring from here. When it's vertical, it is looks like it's 29 centimeters. So we'll go with 29 centimeters when it's vertical from here. And we'll take it from there. Okay, there is vertical from this one, approximately vertical. Try to keep it there. Okay. Now I'm going to multitask. You might have seen me get hit in the head by this on the very last, the upper right trial. It was the last trial, as it turns out. That's why I wear safety glasses. I'm glad I did. It didn't hit me in the eye, but still, there was this thing undid and released, and it wasn't the most pleasant thing. And it wouldn't have been if it hit me in the eye. So anyway, safety glasses do their job sometimes. Okay, so now I'm going to go from the innermost one. And we know that that's 31 centimeters from the center of the rotation to that clip. And with the spring stretch, it looks like that is about (25.5 centimeters is what I'll go with for that. Go with 25.5 centimeters for the stretch of the spring when it is vertical like this. And what I'm noticing is it gets harder and harder to keep it vertical the shorter this radius is. It might just be me, but that's what I'm experiencing. So I'll do the best I can. And here's the first one. Following this, I'll multitask again. Congratulations, you're almost done with the measurements, or the main part of the measurements, which is measuring the period, which we'll talk about in just a minute, but the period of the weight here as it goes around. I'm going to do something now that I haven't done in other labs. You get the bonus of this, and you get the bonus of me doing it, and you just get to take the measurements and hopefully see it more clearly than you would have otherwise. And I get to see it too. And what I'm going to do is I'm replacing the spring with a rubber band. This is the spring, this is the rubber band. And what's different about them is they have a different elasticity. It's going to take a different amount of force to pull the rubber band the same distance that it took to pull the spring. And I'm only going to do this for just one of the measurements. I'll do this for the one that's the second furthest out. That is the one that is the radius of 37.5 centimeters from here to here. And I just measured the rubber band. The rubber band has a radius when it's there of the same as not a radius, but a stretch of 31.5 centimeters, which is what the spring had. Close enough. I mean, there's a little bit of uncertainty here. But I'm going to do the same thing that I did with this that I did with all of the other spring cases. And I'll see if I can at least get a couple repeats. I'd like to get at least one set, and maybe I'll get a few more if I have the energy to get all 5. So, but I'll at least get the one, and I'm about to show you that now. Try to make it vertical. Probably going to have to spin it a lot faster. Okay, if the rubber band doesn't break, I'll at least get maybe 1 or 2 more in the multitask mode. Okay, I'm going to undertake now measuring the force that it takes to stretch, whether it's the spring or the rubber band, to the lengths that are needed to represent how much they were stretched when the item was rotating earlier and the string was in the vertical position. So for the rubber band, the length was 31.5 centimeters that it was stretched. So I'm going to stretch it now, and you can actually see the force. Hopefully you can see the force here. I'll press collect. But it's really the number that you can see, the digits that you can see, that'll be the more precise value. But I'll have my force sensor going to 31.5 centimeters is about right there for the rubber band stretch. And that looks like it's going to be about 6.2 meters, something like that. I'm sorry, 6.2 newtons. It seems to vary a bit, and I don't trust this rubber band very much. I don't think it's long for this world. So that's why I didn't do 5 of the other measurements, because I'm not sure how long it's going to last. So we're going to repeat this with the spring in just a moment. Okay, I'm going to repeat what we just did with the rubber band now with the spring. So I'm going to use the force sensor here. You can actually see the measurement as I'm doing it. And I'm going to stretch the spring. I'll start with 25.5 centimeter stretch. That was when it was at the closest position. So I'll go to 25.5 centimeter stretch. And hopefully you can see it's about 3.1 newtons. Now I'm going to go to 29 centimeter stretch. At 29 centimeter stretch, looks like it's about 3.7 newtons. Now I'm going to go to 31.5 centimeter stretch. Looks like it's going to be about 4.1 newtons. Now I'm going to go to 35 centimeter stretch. And at 35 centimeters, it looks like it's about 4.6 newtons. Okay, so there's your data set. And in the next set of videos, I will give you an example of how you can work with these data to compare the centripetal force to the actual force associated with the spring, the tension force associated with the spring, also often called the spring force. All right, one more quick video on the rubber band. I'm a little frustrated because it's not very consistent in terms of the force measurement. I'll go ahead and zero the sensor first, and then I will make sure it's zeroed when there's no force acting on it. Okay, zeroed now. I'm going to stretch it to 31.5 centimeters again, and it seems to be different every time. Very interesting. Now it's showing about 7.5 newtons. A minute ago it was 9-something newtons. So I don't completely trust this force measurement for the rubber band. I think the rubber band is a variable force depending upon exactly where it's stretched, which is a little odd, but rubber is not a very consistent elastic material. So I'm not sure we'll use these data, but it's somewhere between 6 newtons and 9 newtons. Right now it's showing more like 7.2 newtons at 31.5 centimeter stretch. So this is something to keep in mind as you, if you choose to look at the rubber band. My recommendation is that you pick 3 of the 4, that's actually 5 different situations we had. We had 4 different spring lengths and 1 rubber band length. Take any 3 of them for the analysis we'll do in the subsequent videos.